Have you ever pondered if two events occurring at different locations can happen at the same time? Welcome to the mind-bending world of simultaneity, a concept that challenges our everyday understanding of time and space. It's a notion that comes straight out of Einstein's theory of relativity, and it's about to turn your perception of the universe on its head. Let's dive right in. The idea of simultaneity suggests that two events happening at distinct places can indeed occur at the same time. But here's the catch. This simultaneous occurrence is not universal, it's relative. It depends on the observer, and more specifically, the speed at which the observer is moving. So, let's imagine two events. A pair of fireworks exploding in the night sky, for instance. To an observer standing still on the ground, these fireworks might explode at the same time. This observer would say the events are simultaneous. But now, picture a second observer whizzing past in a super speedy train. From this observer's perspective, the fireworks don't explode at the same time. The firework closer to the direction of the train's motion seems to explode first. So, for the second observer, the events are not simultaneous. This is simultaneity in the world of relativity, a world where time and space intermingle and the sequence of events can change based on your motion. It's a world where your speed shapes your reality. It's also a world that challenges our everyday perception of time. We're used to thinking of time as something universal, something that ticks away at the same rate for everyone, everywhere. But simultaneity tosses this notion out the window. It shows us that time can be as flexible as a rubber band, stretching and shrinking based on how fast we're moving. So the concept of simultaneous isn't as straightforward as it might initially seem, is it? It's a fascinating, mind-bending concept that takes us one step closer to understanding the true nature of our universe. So, how does this concept of simultaneity work, you might ask? Well, let's break it down. Imagine two lightning strikes occurring at the same time, equidistant from a stationary observer. To this observer, both strikes appear to hit simultaneously because the light from each strike reaches them at the same time. But what happens if there's a second observer, one who is on the move? Now, this is where things get interesting. The moving observer, let's say they're moving towards one of the lightning strikes, will see that strike first. Why? Because they're moving into the light from that strike, effectively meeting it halfway. The light from the other strike, however, still has to travel the original distance to reach them, so they see it later. This might seem counterintuitive because we're accustomed to thinking of time as absolute, something that's the same for everyone, everywhere. But in reality, time is relative, and this is the essence of simultaneity. Now you might be wondering, but the lightning strikes happened at the same time, right? Yes, they did. But time, as we've just discussed, is relative. It's dependent on your frame of reference. Think of it like this. If you're standing still, time might seem to move at a certain pace. But if you're running, time might seem to move faster. You're still experiencing the same events, but your perception of when they occur changes based on your motion. So, in the case of our moving observer, even though the lightning strikes occurred simultaneously, the observer perceives them as happening at different times because of their motion. This isn't about the speed of the lightning or the light itself, but about the perception of the observer in motion. Therefore, the concept of simultaneity is all about perspective. It's about how the motion of the observer can affect the perception of simultaneous events. Hence, what we perceive as simultaneous could differ based on our own relative motion. Now, where does the speed of light fit into all of this, you might ask? Well, let's delve right into it. The speed of light is a constant, a universal speed limit, if you will. No matter who's observing it, no matter what their motion or the motion of the source of light, the speed of light remains the same. It's a staggering 186,000 miles per second. And nothing we know of can break this cosmic speed limit. Now, you might be wondering, what does this have to do with simultaneity? That's where things get really interesting. You see, the constancy of the speed of light has profound implications on our perception of simultaneity. Picture two events happening at the same time, but at different locations. Now, if an observer is stationary, they would perceive these events as simultaneous. But if another observer is moving relative to the first, they might not perceive these events as happening at the same time. This discrepancy is because the light from these events doesn't reach the observers at the same time due to their different states of motion. The speed of light is always the same, but the time it takes for the light to reach different observers can vary. And since our perception of when an event occurs is based on when the light from that event reaches us, this difference in arrival times can make events seem simultaneous to one observer, but not to another. In other words, what is simultaneous to one observer might not be simultaneous to another. This is the crux of the concept of relativity of simultaneity, an idea that emerged from Einstein's theory of relativity. It's a mind-bending concept, isn't it? The idea that our perception of simultaneity can be influenced by something as fundamental and unchanging as the speed of light. Isn't it fascinating how the speed of light plays such a crucial role in our perception of time and simultaneity? So the next time you think about time, remember, it's all relative. Does this concept of simultaneity have any implications in our everyday life? Let's dig into that. At first glance, you might think, surely this highbrow concept of simultaneity can't affect my daily routine. And you'd be mostly right. The effects of simultaneity are usually negligible at the small scales and everyday speeds we live in. The time distortions caused by the relative motion between two observers are so minute that they become almost impossible to detect. However, the key word here is almost. There are instances where the effects of simultaneity are not only detectable, but also significant. Consider the global positioning system, or GPS, that we use so frequently. The satellites and receivers in a GPS are moving relative to each other. Now, this relative motion, combined with the vast distances involved, creates a scenario where the effects of simultaneity come into play. The satellites in the GPS system are constantly sending out signals that include the exact time the signal was sent. The receiver, say your smartphone, picks up these signals. By comparing the arrival times of signals from different satellites, your phone can triangulate your exact location. But here's the catch. Even the tiniest discrepancy in the time recorded by the satellites and your phone due to their relative motion can lead to significant errors in location determination. This is where Einstein's theory of relativity steps in. It provides the necessary corrections to account for these time discrepancies, ensuring that your GPS can pinpoint your location with remarkable accuracy. So every time you use your GPS to navigate, you are, in a way, experiencing the practical implications of simultaneity and relativity. Isn't it fascinating how these seemingly abstract concepts weave their way into our daily lives? So the next time you're using your GPS to find the quickest route to your favorite coffee shop, remember, you've got Einstein and his theory of relativity to thank for that perfectly brewed cup of coffee waiting for you at the end of your journey. Einstein's theory of relativity and simultaneity, seemingly abstract, actually have practical implications in our lives. So we've explored the concept of simultaneity, but what does this all mean for us? Let's draw our journey to a close by summarizing the key points we've covered about simultaneity. This fascinating concept, deeply rooted in the realms of physics and philosophy, challenges our conventional understanding of time and space. At its core, simultaneity suggests that two events occurring at the same time for one observer may not happen at the same instant for another observer in motion relative to the first. We've delved into how our perception of time can be altered by our relative motion. This phenomenon, known as time dilation, is a cornerstone of Albert Einstein's theory of relativity. It illustrates that time is not an absolute entity, but rather it's subjective and can be influenced by how fast we're moving. We've also explored the role of light's constant speed in shaping our understanding of simultaneity. The speed of light, a mind-boggling 186,000 miles per second, remains constant for all observers, regardless of their motion or the source of light. This invariance of light speed is a fundamental postulate of special relativity and plays a key role in the concept of simultaneity. We've seen how simultaneity manifests in everyday life, albeit subtly. For instance, GPS systems, which we rely on for navigation, account for the effects of time dilation and the constant speed of light to provide accurate positioning data. In essence, simultaneity serves as a reminder that our perception of reality is shaped by our position and motion in the universe. It nudges us to consider that our understanding of time and space is not absolute, but is influenced by our relative motion and the constant speed of light. In the grand scheme of things, we're not just observers, but active participants in this fascinating universe where time, space, and simultaneity intertwine in ways we're only beginning to understand.